Good morning, friends and family. We'd like to welcome you all to our final presentation of the senior thesis project. We are SPS. I'm Ali Abdelal. I have with me Marwan Hazem, Nwishy, and Mahmoud Sultan, and we will be talking about our senior project. Our supervisor is Dr. Sherif El-Kassas, and we'd like to thank him very much for the efforts that we've put in through the past 2 semesters. Okay. The project overview that we're going to talk about today is an e-procurement system. Before we start, we need to know what an e-procurement process is. The procurement process includes the preparation and processing of a demand as well as the approval of payment. Through our research, we have found that paper-driven procurement can cause businesses and governments huge amounts of money due to improper planning, due to security issues, and some ethical issues like unfairness of availability of information. In this slide, we have shown that 60% of bribery in general are due to procurement, and this is all the research that we have done. Okay. We have found the need for an e-procurement secure and transparent system to eliminate the corruption and inefficiency that is plaguing the procurement process. We observe the need for streamlining the procurement process due to the rampant corruption that causes an unfair environment for all the businesses and sellers in the market. And we want to utilize this market gap by producing a product that offers a fair ground for all its sellers. So all these challenges can be solved using a secure and transparent e-procurement system that is used with the blockchain network. The blockchain network is used. The blockchain network. Is there a problem? Continue or? Okay, the blockchain network is used by cryptocurrencies around the world these days as it's the safest and most secure method. It is used as it will increase the transparency, security, and accountability due to the blockchain and how it is maintained. This will be discussed even more throughout this presentation by my colleagues. And now my colleague Marwan Hazem will talk about the system architecture and design.
Thank you, Ali. So now I'll be talking a little bit about the system architecture and the design. First of all, the blockchain system, as Ali mentioned, we'll be building our system over the blockchain. So by this, the blockchain system is a way to store information, store data, and there's no way to hack it or cheat the system. So the blockchain system is a digital ledger where it's distributed among multiple computers on a single network. The first problem that we face is that it is still a new network, it's still a new technology. We still didn't have enough documentation or enough community to help us with it. So the first problem that we tackled, how should we tackle this problem? How should we implement this problem? We started off by a little bit of research and prototyping. After a little bit of research and prototyping, we found out that there is a framework that's called Hyperledger Fabric. Hyperledger Fabric was founded in 2016, and it is developed by IBM. Multiple projects was done by this framework, and as you can see, Walmart in the US has done a project to provide transparency. Another project was done in Dubai to provide security. And this is the goal of our e-procurement system. So now I'll dive a little bit deep into the architecture of this framework to understand the blockchain network more. First of all, it has a permission network. Unlike the normal blockchain, it's not a public network, it is a permission network. By this, I mean that every person has some permissions in which he or she can access some things and other can't. And also it has confidential transactions. So we can allow some people to do things, but to see the transactions such as the admin, but other users can't see. And this is what we need to provide transparency. And finally, it's programmable using Java, JavaScript, and Go. And we use JavaScript to write our chain code. The chain code, it's just the process of the business network. This is the most important part in the blockchain, the ledger. The ledger, which is distributed among multiple computers and nodes among the network. The ledger consists of two parts, the transaction log and the state log. The transaction log, we use two database management systems. One is LevelDB and one is CouchDB. LevelDB is the one is used for transaction log. It is used for creation and retrieving only. By this, I mean that the database management system doesn't allow update or deletion of object within this database management system. And the other one, CouchDB, which is used for the states, is allowed for creation, retrieving, updating, and deletion of objects within the database. By this, I mean that any object would alter the state within our network would be entered into the transaction log, and no one can, literally no one, even us, can delete this. And this is what we want to provide, a transparent, secure e-procurement system. Next slide, please. Now, a little bit about the workflow. First of all, we have the client, which is the user. He hits an endpoint, which goes to the endorsing peer. The endorsing peer comes back with a response saying, okay, you are allowed to do so, or you're not allowed to do so. The most important part in our system is the orders peer. The orders peer is the one that makes sure that every peer within the organization have the same ledger. So here we can notice that in the distributed system, we have ledger within each organization, and this ledger should be the distributed ledger and should be synchronized among all of them. And now my colleague Islam Nwishy will continue with the system design and demo. Thank you.
Hello, everyone. Thank you, Marwan, for your amazing explanation. So when we thought about our system, we thought, how can we make it fit as many industries, as many organizations as we can? And the more we researched solutions for that, the more it became more complicated, as different organizations use different workflows for their for how they process orders and eventually making them become contracts. So to make a flexible structure for all organizations to follow without forcing them to a workflow of our own, we then started coming up with ideas of making a contract pipeline. We call it a pipeline because it basically the process where an order goes through different steps until it becomes a contract, and the vendor can between the vendor and the
morning, everybody.
Morning. Can you hear us? Okay. Between yes, until it becomes a contract between the vendor and those who made the order. So the first step of our contract pipeline is pretty much very obvious. It's the departments. Each department, the order goes through each department sequentially, and each department has the authority to accept the order or reject it. But this wasn't enough for us. We thought about the legalities of such thing and how many organizations would want some form of documentation to be generated so that they can download it and use it afterwards, or make people sign it. So we give an option for each node in our pipeline to generate a document. This document on itself is very flexible, as it's basically a normal Word document with certain keywords that are replaced during the generation of the document to create the final document, whatever way it is. So it could be a request for quotation, it could be anything else. The final part of our pipeline is the cancel behavior or rejection behavior. And when we researched it, we found that there is pretty much like just two ways that, or two consequences for rejecting an order. And that's either you cancel the order altogether, or it returns it back for review by a previous node in the pipeline. So now I'm gonna show you our demo. This demo, we created a front end just to demonstrate our system. This is again just for demoing purposes. Our system is the blockchain, is the APIs. It's not the front end and stuff like that. But we thought that like the best way to show our project is to show how it can be used. So we're gonna start. So first off, we have the admin signing in to his organization. So they have departments, they have documents and so on. These are all stuff that organization based. Now we're gonna add a department to our organization, and that's very important because an interesting thing is gonna happen right now. So this is our so this is our transaction log. This is pretty much our blockchain. This is or a reflection to the transactions happening on the blockchain. These transactions cannot be deleted, and as you can see, there are transactions before it, not only the one we just did, and that's because we were testing our system actually, and these are transactions we made, and even us, as Marwan mentioned, even us can delete these transactions without deleting the whole network. So now we're gonna look at the transaction. We see that a participant has been added, and it's been added by an organization. The organization we just created that has a unique ID. And here you go, that's that data we just entered. It's timestamped and it has a unique transaction ID that can be traced at any point in time. We're gonna move over. These are the documents where I'm gonna just skip it. It's just normal documents. We can name it and pretty much upload the template that you want. And now that's the more important part. Before we see that, we chose this this process specifically because it shows it highlights that how the actions of the user reflect in the blockchain. There are many features in the system that we wouldn't be able to show you right now due to time constraints. But we hope that this little process will give you an idea of how things should work. So we just fill out the data for the order. We have like the end date for the order and the end time. So after that, the order will be invalid, and we chose the default our pipeline. Right now, the company has only one pipeline, which we call just default, and it's similar to the one I just showed you in the previous slides, but like the naming is a little bit different. So we have procurement system, it passes on to a technical system, a marketing system, and so on. So we create an order. Now the order has been created, and now we're gonna look at our transaction log. And we see that a couple of things have been added, a couple of assets. One of these assets is basically the actual order, and another asset, the whole data, and another asset is the state of the order, or the process where the department itself has to basically act on. So the department will accept or reject the order, and that's basically the node that's creating this. It's creating the state and waiting for a change in its decision and state. So we log in as the procurement department, and we see the order here. We wanted also to show another thing. This is unedited, and we wanted it to be unedited so that you can see like the entirety of the process and in a realistic manner. But that's just logging in. Okay, So we have our technical department on the right, our procurement department on the left. And as you can see, the order only shows up in the procurement department section, not in the technical department, because the technical department does not have the sufficient permissions and access to this specific node at this specific time. The procurement department will then, I move too forward. I moved a little bit too forward. Yeah. The procurement department will accept the order, and now it shows up at the technical department side. The technical department side has, or the technical node at least, has the cancel behavior of return for review. So for this reason, and we wanted to demonstrate that, so the technical department will now reject the offer a little bit. There. And here we go. The same order went back to the procurement department to re-review the decision. Now looking at a transaction log again, you can see multiple things have happened, assets have been updated. And if you look at the participant, the IDs are not the same because different orders made different actions. And all these actions are logged again. All these actions exist on the blockchain. And if for whatever reason, some magician managed to impact something in the blockchain, the other nodes will invalidate this action, and it will actually refuse to make that change unless it's synchronized between all the distributed systems we have. So that's the verdict that is rejected, and an asset have been created again for the procurement department to make their decision. We're just showing the names of the organizations and stuff like that. Yeah, so we move on. Yes, so this time we approve in the procurement side, and then we approve in the technical side. And now the order doesn't exist on either because it's the legal department time to make a decision on the process or on the order. So we log out, we log in again as the legal department. Forgot to remove the names, sorry. So yeah, we have the legal department, and it's now they can approve also on the order. At this part, we wanted to show what if for some reason someone maliciously tried to like overrule an action that has already been made. So this person here approves first and then gonna reject after the approval. And because we didn't make any fail safes, the request actually goes through. But yeah, they're gonna reject again, and the request actually goes through. But because the approval was the action made first, the system will act only on the approval. And that's good and all, but another interesting thing will happen. So we're gonna here show you that the approval behavior continued, and now it's time for offers and things like that. But when we go to our transaction log, we can see that both the actions were logged, the rejection and the approval. Although the rejection had, like, we didn't act on it on our system, there was nothing that happened after the rejection, but it was logged that someone at least tried to overrule an action that was already made and tried to manipulate a state pretty much when they had no right to. We're gonna talk about this part later on. But yeah, that's pretty much it. Something I wanna point out that this front end wasn't directly talking to our blockchain. Instead, it was talking to like a middleware server that's a middleware backend server that's made in Django. And a very like legitimate question would be, why would you make basically a backend for a backend? And the reason why we did so, well, a lot of reasons, but one of which is that we wanted to give our end users the ability to not only customize their front end, but also the ability to do some more complex calculations in how they process offers and stuff like that. Things that we wouldn't necessarily be able to do on the blockchain because of like how heavy the processes are. But they can, of course, log the results after they're finished. The other thing is that it allows us to save documents and images and stuff like that, and then hash it and send it to the blockchain rather than saving the actual document, which is like a very heavy process to save on a blockchain. But the actual like very useful thing we believe is that we made this Django backend open source, and my colleague Mahmoud Sultan will talk about it later, but we made it an open source because we wanted it to be more of a tutorial for our end user. That's how you can use our blockchain system, and that's how you can use it to create a bigger system that and a more customizable system that fits your organization. And we can do that because our system, our blockchain is permissioned. And in this screenshot here, we're showing the access token, or that's the token that must be sent on every request so that it gets processed. And this authentication token is created once we create the certificate for the organization. And the certificate is made by us. So no organization can just use our system without basically going through us first, so that we create the certificate, we give them the access token, and then they can use it in their backend to communicate with our system. And we can see here, when we try to communicate with any of the endpoints, we get a 401 unauthorized response. We also have another type of permissions, which is action-based permissions, and that's that's basically even if the company or the organization can access our system, we don't want all people on the organization to do all things or to access everything. So for instance, here we have an organization department user trying to make an offer, which is something they can do. And as we can see here, that's indicated in the response that that organization user does not have the create access to create an offer, which makes sense for obvious reasons, because the sellers are the ones who are supposed to make offers. And now I'm going to leave you with my colleague Mahmoud Sultan to talk a little bit about our empowerment and outcomes.
Thank you, Islam. So now I'm going to talk about our project outcomes and empowerment. So since we decided to provide a commercialized product, so our product will be divided into two parts. The first part is the core part. So the fully functional blockchain network, which will be provided as a blockchain network itself, in addition to the REST server, which will help to communicate with the network. So our users or our customers will receive the fully functional permissioned blockchain network with the REST server. The REST server, as you can see in the top right corner, the set of APIs that will be provided to our users. In addition, we are going to provide an Angular admin front end, and it will be provided to the customer for the admin user. The admin user will have the access, the admin web page will be used for the admin to view all the transactions, the departments, the assets like the offers and the offer states. The admin can edit or change or view any of the mentioned departments or assets. However, as my colleague Islam mentioned, that any change by the admin will also be reflected to the log or the level DB, which will never be deleted only by deleting the whole network. Second part, we are going to provide an open source, as my colleague Islam mentioned, an open source backend wrapper using Django. The wrapper itself will be provided as an documentation for how to use our APIs or how to use our provided network. It can work with any front-end REST framework. And now I'm going to show you briefly the wiki page for our GitHub repo. So we have the project idea, the table of contents, a documentation for each API we are going to provide and how to communicate with the network. And finally, my colleague Ali Moussa will wrap up our presentation.
In conclusion, our product should be integrable with any organization. It is a fully product that is commercialized and should be used in an easy way, like any organization can come and take our product and just integrate it with its UI. Although we have found that a fully automated system would be the most secure method, but it is not the most useful one for companies, as the human element is still a major driver in this complex process. Hence, we would like to leave for some amount of customization for any organization so that they could form their own workflow. This field of inquiry is very important as at its center is a concern for helping governments and organizations become much more secure and transparent, and that will lead for a much more confidence and trust, which will lead to a much more profound procurement process. We've planned ahead, we've stuck to a very good time plan, reasonable one, and now we can say that our product is usable and ready, but I have to add that we have built it in a way that we can keep on adding features and accommodating for the future. There are a lot of technical details that we could have gone through, like my colleagues have mentioned, but due to the time constraints, we really could not. So if you have any questions, feel free to ask. Thank you very much for coming.